This is some parameter adjustment of our VO, the gain frequency, and this dynamic range. When everyone goes to adjust the VO, these three are crucial. Let's talk about this frequency first. What does it amount to? It's like I'm drawing a line for you. So let me show you, for example, these two waves are different. This indicates that the frequencies of the two types of ultrasound are different. You see the ultrasound frequencies. It's lower because it has a long wavelength. Its frequency is a bit lower. And this has a short wavelength. You see the high end to another high point. The distance between them is very short. It has a very short wavelength. A very short wavelength means that its frequency is relatively high. Okay? Our ultrasound frequency is the same as the two pictures I'm drawing now. Once your frequency is low, your penetrating ability will be very strong. If you look carefully, you will find that the frequency of our rectal linear array probes is mostly about 6 o'clock, 6 to 5, or 7 to 5. And if it is a large protrusion probe, a shock probe, or a rectal shock probe, most of its frequencies are on 3.5. These two probes are different. His frequency is also different. This is 650. This is 3.5. And this burst probe has a significantly lower frequency than this linear probe. That means that this sudden shock probe has one advantage. That is, its penetrating ability is stronger. You get the idea. It's looking at different animals with different probes. This is one of its original intentions as our frequency increases. The weaker our ability to penetrate, you can see the depth of penetration becomes shallower. Then the penetration becomes weaker again. What does this depth of penetration affect? For example, this is our probe going down and emitting ultrasound. The deeper your ability to penetrate, you can see an image very deep if your penetration ability is weak. You only see shallow images. This is the difference between the two of them. When we choose the probe again, if you want to see something shallow, so you better go for a rectal array. If you want to see the deep part, you choose the rectal convex array. But people generally don't use many deep parts because of what you're doing deep down is you're looking at older fetuses. And we don't need to use a slow frequency at all for older fetuses. We can extend the probe a little more and we can see, and in most cases, we're looking at the shallow parts that includes our ovaries, including our early pregnancy tests are in the superficial area. It is only said that he was in the body part after a long pregnancy. This is a discrepancy between the two frequencies. One with strong penetrating ability, a weak penetration ability. In addition, it will also cause a problem that affects the resolution. We can understand resolution as clarity because the higher your resolution, the clearer your image feels. At this time, the advantages of high frequency are reflected the advantages of high frequency. The higher your frequency, the higher your resolution, it means that your clarity may be better. And the lower the frequency, the worse your clarity may be. This is also why I just recommended that you choose a probe. It is recommended that you choose an advantage of rectal linear array probes. This is due to the impact of one of these two frequencies